Welcome to InsectTech's Ethical Hacking course videos, module Firewalls. In this video, we will look at introduction to firewalls, how firewalls work, and what are the types of firewalls, and a deeper look into Windows firewall and its capabilities. Finally, we will look at a couple of demonstrations where we will see how a Windows firewall can defend against Nmap scans. So let us first start with the very basic definition of a firewall. A firewall is a hardware or a software that protects a computer or computer network from being compromised by the attackers. And now let us see how a firewall works. You can see a firewall needs to be connected to a minimum of two network interfaces, one which is supposed to be protected and the other which is exposed to attacks. You can see that in this figure, this firewall is connected to two interfaces. The first one is a network which has to be protected by this firewall, and the next interface is actually exposed to attacks, which is actually connected to internet. So this is how a firewall will actually work. The firewall will try to stop the attacks which are actually coming from this internet to this network, so that this network will be protected by this firewall. Now let us see how these firewalls work. Generally, when a firewall is connected to a network, the administrator will try to define some rules called access control list. These rules will generally be like what are the addresses, what are the IP addresses that are to be blocked by the firewall, and what are the IP addresses that are to be allowed, what are the protocols that are to be blocked or allowed. Such rules will be containing such kind of information. Now when a packet is passing through the firewall, the firewall will try to examine whether the packet is meeting the rules defined in access control list or not. If the rules are met, the packet will be allowed to pass through the network, to pass into the network. Otherwise, the packet will be dropped by the firewall. And firewalls generally maintain a log of important activities inside the network, so that the administrator can see and examine what are the activities that are being done. And firewalls can filter contents on the basis of address, protocols, packet attributes, and state. Now let us look at some kinds of firewalls we have. The first one is packet filtering firewall, and circuit level gateway firewalls, and application level gateway firewalls, and stateful multi-layer inspection firewalls. The first one is packet filtering firewalls. Packet filtering firewalls are normally deployed on the routers which connect the internal network to internet. And these packet filtering firewalls can only be implemented on the network layer of OSI model. And these packet filtering firewalls work on the basis of rules defined by the access control lists. They check all the packets and screen them against the rules defined by the network administrator as per the ACS. If any case any packet doesn't meet the criteria, then the packet is dropped and logs are updated about this information. This is what we have discussed in the previous slide, and we'll have a demonstration of how it is actually done later in this presentation. And administrators can create their ACLs on the basis of address, protocols, and packet attributes. And this is about packet filtering firewall. We have a couple of advantages and disadvantages with these packet filtering firewalls. The biggest advantage of packet filtering firewalls is cost and lower resource usage, and best suited for smaller networks. If you are using a smaller network, you can simply build a packet filtering firewall. And the disadvantage is these packet filtering firewalls can work only on the network layer, so that they may be vulnerable to some kind of spoofing attacks at times. And the next one is circuit level gateway firewall. Circuit level gateways are deployed at the session layer of the OSI model, and they monitor sessions like TCP three-way handshake to see whether a requested connection is legitimate or not. It means major screening happens before the connection is established. The disadvantage over here is if an attacker tries to perform some kind of attack after establishing a connection, this particular circuit level gateway firewall will not be able to detect it. And information sent to a computer outside the network through a circuit level gateway appears to have originated from the gateway. This helps in creating a stealth cover for the private network from outsiders, so that anybody inside the network will be anonymous to the people outside the network. And we have advantages and disadvantages. We have seen circuit level gateways are comparatively inexpensive and provide anonymity to the private network. And circuit level gateways do not filter individual packets. The disadvantage here is, after establishing a connection, an attacker may take advantage of this. That's what we have discussed in the previous slide. And the next one is application level gateway firewalls. These are very, very important kind of firewalls which we generally see in our daily life. Application level gateways work on the application layer of the OSI model and provide protection for a specific application layer protocol. Proxy server is the best example of application level gateways firewall. We generally see in colleges, if you browse some specific website like facebook.com, your firewall will block it, and that firewall is actually application level gateway firewall, which is actually a proxy server. And the next one is application level gateway would work only for the protocols which is configured. For example, if we install a web proxy based firewall, then it will only allow HTTP protocol data, and they are supposed to understand application specific commands such as HTTP GET, HTTP POST, as they are deployed on the application layer for a specific protocol. And these application level firewalls can also be configured as caching servers, which in turn increase the network performance and makes it easier to log traffic. For example, if one client is trying to connect to google.com, and if this particular application level gateway firewall is deployed, it can be used as a caching server, so that it can log the cache of the Google server, and it can provide the Google server google.com site to the client without actually trying to connect to the original google.com. So this is one more advantage with application level gateway firewalls. And the next one is stateful multi-layer inspection firewall. This stateful multi-layer inspection firewall is a combination of all the firewalls that we have studied till now. These firewalls can filter packets at network layer, and these firewalls can check for legitimate sessions on the session layer, and they also evaluate packets on the application layer. This is why we are actually calling it a combination of all the firewalls we have discussed till now. And stateful multi-layer inspection firewall can work on a transparent mode, allowing direct connections between the client and the server. And stateful multi-layer inspection firewall can also implement algorithms and complex security models which are protocol specific, making the connections and data transfer more secure. We'll actually have a nice demonstration of how all these things can be performed by a firewall using Windows firewall. We'll see that. And these are the advantages of firewalls. The first one is software firewalls, and the next one is hardware firewalls. First, now let us try to understand what are the advantages of software firewalls. These are cheaper. Software firewalls are usually meant for personal use and for home use, and these are easy to configure. And where in the case of hardware firewalls, speed is the best advantage, and security, these are less prone to attacks, which increases the overall security of the network. And no interference, a box which is separated from other network components can be managed easily and doesn't overload the operating system. And the box can be easily redeployed anywhere in the network with minimal interference to the network as well. And coming to the disadvantages of firewalls, if you take software firewalls, they'll actually be installed as a normal software on a system, so that they take up system resources and slow down other applications. and these software firewalls are not suitable for organizations or office networks because an attacker can easily take down the entire network using a denial of service attack if the network is using a software based firewall. And coming to the hardware firewalls, their security is very high, but these dedicated hardware firewalls will definitely cost more. And hardware firewalls require technical knowledge to install and manage them, and this knowledge will be vendor specific at times. If you purchase a hardware firewall from one vendor, the technology they use may be different from another vendor, so the knowledge of a specific vendor should be there to manage the hardware firewalls. And now let us look at how to bypass firewall restrictions. If it is blocking a specific IP address or a specific website, we can simply use proxy servers to bypass these firewall blocking. And in this video we are not actually going to discuss how to bypass these firewalls. If you are really interested in understanding how to do that, please go through the module proxies, and for application or protocol specific blocking you can go through HTTP tunnel concept under proxies module. And I'm just going to the next slide. Now let us look at Windows firewall. Windows firewall is host based firewall, which means it will be installed on a specific system but not at the perimeter of the network, and this is actually available for free of charge and is automatically enabled when we install a Windows operating system. It provides defense in depth. It means generally network layer firewalls protect the perimeter of a network from malicious intruders trying to probe the network or exploit a vulnerability on an internal server. Unfortunately, users don't always connect their computer to a network which is actually protected behind a firewall. If you take an airport or if you take a hotel as an example, our computers or laptops will connect to an unsafe network outside the secured network perimeter. This is where a host based firewall such as Windows firewall really comes into the picture. For example, if a virus bypasses the perimeter level firewall, a host based firewall such as Windows firewall, which is actually installed on the computer inside the network, will actually protect the system from that virus attack. And this kind of firewall inspects all the network traffic going to and from the computer on which it is actually installed. And this works very similar to a network layer firewall, wherein a network layer firewall inspects traffic destined to your network, whereas Windows firewall inspects traffic destined to your computer and it drops any inbound traffic that is not permitted by an access control list. We can actually set up these access control lists for both inbound traffic and outbound traffic. It means the traffic which is coming towards our system and the traffic which is going from our system. And Windows firewalls has actually three operating states. One is on, off, and don't allow exceptions. We'll see what it is. Windows firewall can even perform logging. It means if an attacker tries to send some request to this host, this Windows firewall which is actually installed on this host will block the request or will allow the request, and even it can log what is the request that is allowed by this firewall or what is the request that is actually blocked or dropped by this firewall. We'll see how it can be done using Windows firewall. We have a nice demonstration of Windows logging. Now let us see what are these three operating states in a Windows firewall and how they work. I'm just going to my Windows system. I have opened control panel, and now I'm just going to security center, and if you see, firewall is on, and I'm just going down and launching my Windows firewall window, and you can see it has three states. One is on, and another one is don't allow exceptions, and the last one is off. If I check this on button, the firewall will be turned on and it will start protecting our system. And if I check this, even though some exceptions are defined, it will not allow those exceptions by this firewall. And the last one is off. If I check this, the Windows firewall will be turned off and the system will be unprotected. So initially what I'm just going to do is I have just turned on, and let us see what are the exceptions I have defined. File and printer sharing, I'm just editing. You can see 139 and 445 ports are actually opened. It means if any remote system sends a request to this Windows system, these ports 139 and 445 will be visible even if the firewall is turned on. So I'm just clicking OK, and I'm just checking OK here, and let us see. And this time I'm just going to allow my exceptions, and you can see the firewall is on. Now let us check my IP address right over here. ipconfig, and IP address is 192.168.56.103 over here, and I have just checked on, and this time I'm just allowing my exceptions. Just click OK and go to our Windows backtrack system, and let us launch a quick nmap scan against 192.168.56.103, and just wait for the replies, wait for the scan result. Since the Windows system is turned on, the ports should be filtered by that Windows firewall. Great, 997 filtered ports are there, and 3 ports are actually allowed, and these are actually exceptions. Now let us quickly go back to our Windows system and turn on the Windows firewall and just check don't allow exceptions. And now if you scan the if you send the same scan, you can see all the 1000 ports will be filtered. When nmap report is saying filtered, the ports are filtered, it means firewall is turned on. Great, the report is saying all the 1000 scanned ports are actually filtered. It means the firewall is not allowing the exceptions, since we have checked the option don't allow exceptions. And now you can see the firewall is turned on. Now I'm just going to turn off and just click OK. And now if you check, let us perform a simple nmap scan 192.168.56.102, and you can see the response. 996 ports are closed and the rest of the 4 ports are open. We are actually getting all the list of open ports because the firewall is turned off. And you can see the response, 996 closed ports but not filtered. In the previous case, when the firewall is on, it is actually saying 997 ports are filtered but not closed. In this case, firewall is not there and we are actually getting the direct response whether it is closed or opened. And now let's go back to our firewall and we can see, let us turn on this and OK, exceptions are allowed. Now let us simply send a ping request 192.168.56.102. You can see we are getting the responses from the remote system. We can even block these ping requests from the remote system using our firewall. I'm just going to check this don't allow exceptions, and now I'm just going to send a ping request. You can see I'm not getting any responses from the system because the firewall is actually blocking this ping request. Now let us look at how we can perform logging using Windows firewall. You can see you have one option in Windows firewall which is security logging. Right now I have disabled log dropped packets and log successful connections both. Now what I'm going to do is, first I'm just going to log the successful connections but not dropped packets, and the logged results are gonna be there in this specific file, which is under C Windows P firewall.log, and I'm just checking OK and OK, and I want some successful connections, so I'm just allowing exceptions, and let me open a new nmap scan, and 192.168.56.102, and you can see 997 ports will be filtered because of the firewall. Great, 997 filtered ports and 3 ports are opened. Now what I'm going to do is, I'm just going to the Windows system, and let me open the firewall log. You can see it has sent one packet. We got one packet from 192.168.56.101, and that is the destination address is 192.168.56.102. Let me minimize the font, reduce the font size. Now you can see these are the fields we have. The first one is date, and the date is getting logged, and we can see the time. This is the time we got the request. You can see here 12:56 is now, and we just sent this request at 12:55, and this is the action. The first one is open an inbound connection, and the next one is response from the remote system to from the Windows system, which is 102, to backtrack system, which is 101, and the next request is again open, and the next request is again close. And you can see my nmap is sending a TCP open request to this Windows system, and the Windows system is actually sending the close response to the backtrack system. And you can see the next one is action, whether it is open or close or whatever, and the next one is protocol. You can see whether it is a TCP protocol or whatever the protocol, and source IP address and the destination IP address, and source port number and the destination port number, size, if TCP flags if there are any, and you can see all the information over here. And this is how your firewalls can log the successful requests. Now what I'm going to do is, let me log the dropped packets as well. I'm just checking OK, and I'm just going to general tab again, and I'm just not going to allow any exceptions this time. And before this, let us remove everything from here. So now I have removed everything. I have removed all the logs from my log file, and I'm just saving it. I'm just closing it, and let's open a Windows firewall. Go to Advanced tab, and you can see the security logging, and this is where our logs are being stored. Copy the path and check OK, and now open the file. You can see nothing is there, everything has been removed. And this is where the firewall is actually logging the logs. So I'm just going to copy it. I'm just going to open it right now and you can see and this is where now a firewall is going to log the packets. Now I'm just going to check OK, and now if you try to send the same nmap scan and see the results, the firewall is on and exceptions are not allowed. So whatever the packets that are being sent from this nmap tool, they'll be dropped by the remote Windows firewall. So let us wait for the details. All the ports should be filtered. All the 1000 ports should be filtered over here. Yes, great. All the 1000 scanned ports on 192.168.56.102 are filtered. Now it means when it is actually sending some requests, the Windows firewall is blocking those requests and dropping the packets because they are not actually matching the rules that are defined in its access control list. Now let us open the path over there where actual logging is done. Just copying it and let me open that file. And you can see if you go down, it has a very big log. You can see it is actually dropping the packets which are actually coming from 192.168.56.101 to the IP address which is actually the Windows system's IP address 192.168.56.102. and you can see this is actually the requests are actually coming for different ports. Nmap is scanning different ports: 25, 8080, 113, 443 and 143, and port number 21 and port number 135, 139, 1723. The scans are actually coming for different available ports, and all these packets are being dropped by the Windows firewall. So this is how Windows firewall can log your happenings on the network, and even it can block the requests. Even it can secure the system in an effective way. So let us quickly go back to our presentation. And we are done with this Windows firewall demonstration. That's all with this firewalls module. Thank you.